f of x is equal to 2x plus 5 over x plus 3 minus 1 over x plus 3 times x plus 2, where x has to be greater than minus 2. Part A, express f of x as a single fraction in its simplest form. So we need a common denominator. So I can see I've already got an x plus 3 on the bottom of both fractions, so I just need to times this first fraction by the x plus 2. That way we'll have a common denominator. So, putting these two fractions together with that common denominator, the numerator, I'm just going to expand those brackets out. So we've got the 2x times x is 2x squared. The 2x times 2 is 4x plus the 5x. The 5 times the 2 is 10. And not forgetting that we've got the minus 1 as well from the second term. The numerator then is going to be 2x squared plus 9x plus 9 divided by x plus 3, x plus 2. And I can actually do some more simplifying here because that numerator does factorise. That numerator will factorise, so I can do some more simplification. It's going to become a 2x and an x and a 3 and a 3. Because the 2x times x gives the 2x squared, the 3 times the 3 gives the 9, and the 2x times 3 gives 6x. The 3 times x gets 3x, and the 6x and the 3x makes the 9x. We can then see that these two terms cancel out. And so we just find that our f of x is 2x plus 3 over x plus 2. That is my single fraction in its simplest form. Part B. Hence, show that f of x is equal to 2 minus 1 over x plus 2. So I need to convert this into this form, which I can do with a little bit of algebraic division. So if I do x plus 2 into 2x plus 3, the x goes into the 2x 2 times, then multiplying back out, so the 2 times the x is 2x, the 2 times the 2 is 4, taking that away, the 2x minus 2x is 0, the 3 minus 4 is minus 1. So when we divide 2x plus 3 by x plus 2, we get 2 is the whole part, and then we've got the minus 1, which is the remainder, so that still has to be divided by the x plus 2. And that is what we needed to show in part B. Then we are then told that the curve y equals 1 over x, where x is greater than 0, is mapped onto the curve y equals f of x using 3 successive transformations, t1, t2 and t3, where t1 and t2 are translations. Part C, describe fully t1, t2 and t3. So what this is saying is, how does this become this with different transformations? So first thing, the x on the denominator has had 2 added to it. So t1 is like saying f of x plus 2. That's taking the 1 over x and turning it into the 1 over x plus 2. So this is a translation by minus 2 in the x direction and 0 in the y direction. Right, what about the next transformation then? So what happens now to this to make it become this? Well, notice that this is positive and this is negative. So it's been multiplied by -1. So that's like taking the f of x plus 2 function and multiplying it by -1 at the front. So this is a reflection in the x-axis. It's timesing all the y coordinates by -1. So we now have a minus in front. And the final thing to make this look like this is we've got this plus 2 in the front there. So we've had 2 added to it. So T3 is like saying minus f of x plus 2 plus the 2. The 2 is on the outside, so it affects the y coordinates. It's a translation by 0, 2. Oops. And there we go. So the actual answers for part C. This is T1, this is T2, this is T3. You didn't need to include this bit here, that was just me just hopefully explaining it to you in a clear way. You do need the sentences and the vectors.